Hello everyone, welcome back to the channel Code with Abby. In this video, we are going to learn about a very useful concept in SQL Server, that is subqueries. Subqueries are often used in real-world projects, but many people are unsure about when and how to use them. Don't worry, I will explain everything step by step using simple language and real examples. Here is what we will cover in this video. Why do we need subqueries? What are subqueries and where they can be used? Different types of subqueries. Subqueries in select, where, from, and having clauses. Scalar, multi-row, multi-column subqueries. Correlated and non-correlated subqueries. Practical use cases of subqueries. If you find this helpful, please like the video and subscribe the channel for more easy and useful SQL topics. Let's get started. Let's try to understand the definition of nested or subquery in SQL Server. A subquery is also called as nested query. We also call it as inner query. And this is the query which is written inside another query. We will see this in action just in a couple of moments. This kind of query is usually placed inside where clause, from clause, or select clauses in SQL Server commands. The outer query uses the result of this particular inner query, which we call it as subquery or nested query. Let's go and see this thing in action in SQL Server Management Studio. I am in SQL Server Management Studio, and here we are going to create a table to see the nested query demo on this. This table is TBL employees, and this table has got couple of fields: employee ID of integer type, and which is also a primary key, employee name, DOB, email, department, and salary. Make sense? After creating this table, we will insert couple of records to this. So let's go and create this table. I am selecting this script and hitting this execute button. This table has got created. And now let's go to insert these records to this table. Hitting this execute button, the records in this table have been inserted. We can anytime see the records that we have inserted right here. You can see there are 10 records inserted in the table called TBL employees. Make sense? I am going to execute a simple query in SQL Server. That is, I'm going to find the average salary. So the average salary is calculated based on summing up all the salaries and divided by number of persons on there. Make sense? So if you try to display these both of the queries, you see that you can see the average salary is 66,000, and this has come just by adding these up all and dividing by 10. Make sense? Now I'm going to explain you the nested query here. I'm going to write a simple SQL statement here: select all from employees. If I'm saying select all or select a star from employees, it will display all the employee records. But then I am introducing a where clause here. So we are introducing a where clause here, and in this where we are telling where salary is greater than something. If I say salary is greater than 5,000, then it can give you all the employee records whose salary is more than 5,000. For example, let's say if I am going to say 5,000 and I am just selecting this and hitting this button, you can see everybody's salary is more than 5,000. So this has displayed. Likewise, if I am going to change this value to, let's say, 50,000 and going to select this, we can see little less records have been seen here. We have only seen 8 records because there were 2 persons whose salary were less than 50,000. We have still not explored the nested query thing. Now, instead of writing a fixed value here, I'm going to find something from here. What I'm going to find is average of that particular average of the salary. So if you select, this is again a query part and this is another a query part. This section which is outside is called outer query, and the answer or the result of this outer query depends on the value of this query, and that's what this is called inner query, nested query, or subquery. Make sense? So subqueries output is going to help deciding the output of the outer query. So outer query is depending upon the inner query. So how will this get executed? First of all, this section will get executed. So what is the value? 66,000, and then this has got a next value. So this is called inner query. So inner query execute first, and then it gets compared with the salary value of all these employees. So if I'm selecting this all and going to execute this, you see there are 3 records getting executed because there were 3 of the employees whose salary were more than 66,000, because we have seen that the average salary is 66,000 here. And I think now you are able to understand the nested query, inner query, or subquery here. It is a query written and that execute first, and that helps outer query to execute and decide its output. Make sense? I'm going to show you a couple of real-time examples of nested query. Where are those places? Couple of places where you can actually use nested queries in real-time example. First example is employees earning above department average. You see here there are 2 tables. The number 1 table is department table, and we have actually found that there is an admin department, number of employees is 1 and the average is 60,000. Finance department number of employees is 1 and but the average is 65,000. IT employees, there are 4 employees whose average salary is, average of this 4 salary is 8 to 500. And marketing, only 1 guy, salary is 65,000. And sales department, there were 3 persons whose average salary is 46,666. These are the guys here. You can see there are 4 people in IT, this guy, this, and this. If you are finding the average of this salary of these guys, it will come as 82. So coming from here, from here, from here, and from here. Make sense? So what is our problem statement? We are going to achieve it through nested query. And what is the problem statement? The problem statement is we wanted to display all those employees whose salary is more than the average of their department. Okay, it's not like the average of any department. It should be more than the average of their department. So let's say Neha Sharma. Neha Sharma is belonging to IT department and whose salary is 85,000. So what is the average salary of IT department? We have seen here 82,500. Hence we can see Neha Sharma here. This is the output of a subquery that we have written, which we will see in a moment in SQL Server Management Studio. Secondly, John Tabby. John Tabby's salary is 95,000. And why is John Tabby being displayed here? Because John Tabby's salary is the salary which is more than the average salary of IT department. Make sense? Let's go and see this in action. I'm back in SQL Server Management Studio, and here let's go and find out. Our problem is we wanted to display all those employees whose salary is more than the average salary of their department. By this SQL query, we are going to display a couple of things. Is here this one, that what is the average salary of each department. So we have done a group by here, and you pretty much understand how to do these all things. They have already been covered in our sessions. And this is the second thing that we are displaying: employee, department, and salary. Make sense? Here is the inner query that we have written. And how is it inner query working? select average. So we are going to first decipher or understand the subquery or inner query, because outer query is pretty simple. It just shows all the details from employees table. So if we hit this button, it shows all these employee details, where salary is greater than the average salary of employee, where department is same. Once we go and select these three stuffs here, we can see the result out here. So we have just explained this. This particular inner query is going to give the average of that department, and this outer query is going to take the average of the department as an input, and it is going to display that record. And that's why you can see these 4 records here. Make sense? The second example is real-time example is customers who ordered most expensive product. So there are 3 tables: TBL product master, which has got all product details, like product ID 100 is for a sports shoes, which has unit price is 4,000. 101 is formal shirt, which has got 1,000. 102 is trouser, which has got price is 3,000, and likewise we have couple of other products here. TBL customer order is another table, which basically contains the details on who are the customer and who bought what and on which day. Out of these 2 tables, we wanted to retrieve the data, the list of those customers who ordered most expensive products. So we can see here Rohan Gupta and Kumud Shah are the 2 customers who bought the most expensive product. And what was that most expensive product? Watch of 9,000. Make sense? And this is what we achieved through nested or inner query. Here we are going to create couple of tables. The first table that we are creating is TBL product master, which has got product ID, product name, and unit price. The second table is TBL customer, which has got customer ID, customer name, product ID, and date of purchase. We will create these 2 tables and insert records into them. Selected this, selected the second table for creation, hitting this execute button. Second table has been created, inserting the records into it, inserted. Let's go and visualize the data in both of the tables. You can see here the table data is visible. Now let's come to the point where we wanted to show the customer details who bought the most expensive product. You see here we are actually putting couple of nested queries here. So this is an outer query, because this query depends on the result of this inner query. This inner query also has got another inner query. So this is an outer query for this inner query. So there are a nesting of queries here. So let's try to understand this first. What is it going to do? What I'm trying to do is I'm going to say select product ID from TBL master. So I'm going to select all product ID. I mean, it will only give one product ID because it is going to give me the costliest product. So let's say you think of a query where there is a table called product master and you want to show the costliest product. So what will you do? You will actually find the highest price value of the product and you will find that product ID of that particular product. That's what we are doing. Where unit price equals, select max unit price from the TBL master. So it will display the unit price. It will give you the unit price of that costliest product, and that will come into product ID. And here we are getting that particular product details from which product ID is the product ID which has been returned by this inner query. Make sense? Let's go and hit this to see the result. You see here that Rohan Gupta and Kumud Shah, they bought product ID 103, that is watch, and this is the costliest product here. Make sense? Here we have seen another example of nested query. Let's go and see the third example, products never ordered. So we have table product master, table customer order, and we wanted to see if any product was never ordered. And this can also be achieved through nested query or subquery. Let's go and see these also in action. Back in SQL Server Management Studio, and here this is the nested query that we have seen. So if you are executing this nested query, this inner query, if you are executing this inner query, then it shows all the product IDs. Make sense? And then you are saying select all from table product master where the product ID not in this. So this table, particularly customer order table, contains all the customer details who actually did some product ID order. But if any product ID, if it is not part of TBL customer order, that means that was never ordered. And here we are saying not in. So this particular inner query or subquery here will give you multiple records. So if you hit this, you see that it gives multiple records. So one thing that we learned from here is that it is not necessary that the inner query will always give a single or a scalar result. It may give you multiple results as well. And that's where we have written not in. So if any product is not in the output of this, that means that product has not been ordered. So let's go and select this. We see that the sports shoes is the one which has not been ordered by any customer. So you see, this is not the part of this one. So that's why we see that sports shoes is being visible here. With this, we have covered a couple of real-time examples of subqueries. Let's go and try to understand the type of subqueries. We have classified the type of subqueries based on a couple of parameters. The number is based on result type. The number 2 is based on placement. And number 3 is based off dependency on outer query. So we have understood like inner query and outer query. So based on result type, we can think of 3 types of subqueries. Number 1 is a scalar. So we have seen that subquery may return one value. So if it returns one value, it is a scalar value, and we can say it is a scalar subquery. It may return multiple rows, so we can say it will be called multi-row subquery. And it may return multiple columns as well. There are examples I'll show you. So this will be called as multi-column subquery. Likewise, based on placement, if you place the subquery in select, so we call it as subquery in select clause, subquery in where clause, subquery in from clause, and subquerying in having clause. So this way we can, based on placement, we can write 4 types of subqueries. And based on dependencies and based on dependency on outer query, we can think of 2 types of subqueries: non-correlated subqueries and correlated subqueries. Let's go and try to explore each one of them. The first is scalar subqueries. A scalar subquery is a type of subqueries that returns exactly one value. So you see this example. This is the inner query, and which will always be returning a scalar value. Average is just one value. So this kind of queries will be called as scalar subqueries. We have already seen this example, so I'm not taking you for this example. Let's go and explore for next. The second is multi-row, which will return multiple rows. So here in this example, you see this select product ID from table customer. This returns multiple rows, and the outer query has got a predicate called in, based on which it works. So since it returns multiple rows, it is called multi-row subquery. The third is multi-column subqueries. This is interesting. So in this example, we see that the inner query here is not only going to return one column, but it says star. Star means it goes to return product ID, customer ID, and date of return, all 3. And The outer query is making judgment based on this return value. And this is what we call is as multi-column subqueries. Let's go and see this in action. We are back in SQL Server Management Studio to see multi-column subqueries. For this, let's go and create a couple of tables. The first table is TBL orders that we are going to create, has got product ID, customer ID, date of purchase, and amount. Let's go and create this. Table has been created. Let's go and insert a couple of records to this table. Records have been inserted. Now let's go to create another table called TBL returns. So what we are going to achieve it is that there are two tables. Customers have placed some orders and few orders were returned actually. So what we are going to do is we are going to find out which were all the orders which were returned at. Okay. So for this problem statement, we will use multi-column subqueries. So let's go and create this table as well. First, table has been created, and then let's insert into this table as well. Table data have been inserted. Let's visualize the data here. Data has been shown. So there are 6 products here. Out of 6, there were 2 products, customer ID 1001 and 1002, both returned product 1 and product 3. So we will try to write a multi-column subquery here. So the same thing that we are going to do is here, select all from this thing where the customer ID is matching with the customer ID and product ID is matching with the product ID. If both matching, then it shows the existence, and this will return the result in multiple column. And that's where we are going to. So let's say if you are selecting from here to here and hitting the button, you see the multiple column that it is returning. And if you are going to hit this, you see this multi-column subquery getting executed. Make sense? This is based on the placement. So first we can write in the select statement. So in this example, you can see that it returns a single value for each row processed by the main outer query. It is often used to compute derived or aggregated values related to each row. So what we are going to display is, for each employee, their department name is to be displayed. Please note that this department name is not the part of this employee table, but we are going to display that. So how are we going to achieve it? So here you see that the inner query or subquery that we are going to write in select statement, and that's what we call it as based on the placement. So here we are selecting employee ID and employee name. Cool, employee ID and employee name. But for this section, we are going to write a subquery. Select department name from TBL departments, where TBL department ID is, well, employees department ID. And this will be labeled as department name, which we see here. So you see here in select statement itself, we created and we wrote a subquery, and which resulted and which gave us an output here. Your question would be, can't it be achieved in other way? The answer is absolutely yes, you can achieve it in other way as well. Every query that you write has pros and cons. So it depends that how are you going to write that. You are going to put a join between these two tables. How efficient are they? You need to really make a trade-off between that and this. But yes, this is the way that you can also achieve a subquery and write subquery in select statement. Many times you'll find it faster and better than the other implementation. Let's go and see this. So in order to see this based on placement in select clause, let's go and create small tables. The first table is employee ID, employee name, and department ID. Let's go and create this. Created. Couple of records needs to be inserted. Records have been inserted. Now let's create another table. This table is departments table, which contains department ID, and this is kind of master table which contains department ID and its name. And let's go and insert this data into this as well. So if we go and visualize this data, you see that the data is all good here. Employee ID 1, Sumit Kumar belongs to department ID 1001. Please note that the name is not there at the part of this table. You can easily do some sort of join between these two tables and achieve the same result. But here we are trying to achieve this using subquery. So how have we written this nested or subqueries here? So we have already seen that's employee ID, employee name, but instead of department ID, we are going to show the department name. That's why we are saying select department name from TBL department, where TBL department ID equals employee.department ID. And here it goes. See the output. 1001 department ID. That is, you see Sumit Kumar belonging to 1001, that is IT. Neha Sharma belonging to HR, and likewise you can see. So this way you can write a subquery in select statement. Subquery in where clause. So you can also write subquery in where clause. A subquery in where clause is used to filter results from main outer query based on the result of another query. This may return single value, multiple rows, or even no rows. So here, a simple example we have already seen. Select employee name, salary from TBL employees, where salary is greater than the average salary of the TBL employees. So here we have written the subquery in where clause. Subquery in from clause acts like a virtual table. This is interesting. So basically, from section, you can actually write a subquery and which will act as a view or a virtual table or a table which basically physically does not exist. So what it is actually trying to do here is, you see, is the section from here to here is a subquery. And in this subquery, it creates a data set. What is the data set creating? Department and average salary of the department. So you can think of that it creates, it shows department, and side by side of the department, it shows the average salary of the department because it is grouping on the department. So this becomes a data set, a virtual table, out of which this outer query gets some value. What it gets? Department and average salary, from where average salary is greater than 4,000. Got it? So this particularly outer query depends on the data set produced by the inner query, which is written in form clause. Let's go and see this in action. I'm back in SQL Server Management Studio, and here we are trying to get this. You can see there inside this, we have done this query. So if you see this shows that average of each department, and then out of which the outer query. So this inner query generates a kind of data set, a virtual table, a view, and the outer query gets filter data out of this inner query. If I am executing full, it shows me the filtered data. Make sense? So this way you can actually introduce subquery in form clause. The next is subquery in having clause. You can actually write subquery in having clause as well. So in this example, you see that we are trying to get department and average salary of the department, and we are terming is at average salary from TBL employees group by department, having average salary is greater than the average salary from the TBL employees. So here the nested query or inner query has been written in having clause. Make sense? We can see this happening here. So we are just clicking and we see that only one guy getting displayed, that is IT department has got 82,500. So it is based more than the average of everybody. And there are finally two types of queries based on the dependency on outer query: non-correlated and correlated queries. So let's say for this example, if you see It is self-contained query. It runs independently of the outer, and it does not reference any columns from the outer query. So you see, this outer query depends fully on the value of this inner query, and hence it is called non-correlated. If you go and see the correlated section, it depends on the outer query. So for example, it references one or more columns from the outer query of, so this is the inner query, and this value is getting it from depending upon from outer table as well. So the inner query's dependency is outer table as well, and that's why it is called correlated. Make sense? Let's see in this action. So we are here to see the non-correlated. Getting this, you see this answer. And likewise, if you are going for correlated query, it depends on the outside. You can see this is getting executed. So you have joins and subquery options. Which one should be used and when? Definition wise, if you say a query inside another query is subquery, wherein join is combining two tables. Execution is inner query execute first and join all table processed equally. Readability, if you say more readable, because if you see that understanding is proper, you know that the outer query executed based on the outer output produced by the inner query. But in join, you may be putting some efforts to understand. Performance by the nested query, a structure may be slower sometimes, but usually this is faster. Data format often returns a single column or a scalar result, but it returns row columns from both the tables. Use cases, filters, condition aggregators, and the use case for join is displaying full records from related tables. Hope these all points are clear to you. Let's go and try to understand when to use subqueries, when you need to filter rows based on aggregated data, when performing row by row comparisons using exist in any all that we have already seen in the examples. When you want a scalar value from the another table, then in these couple of scenarios you can use subqueries. I'm not telling that these are only the scenarios. You can investigate, you can get more scenarios wherein subqueries can be used, but these were few couple of points which I could figure out for you. When to use join, you want to fetch data from multiple related tables, need to display full row details from both the tables, and for better performance, when subquery logic can be written using join. So these were a couple of points that I could figure out for you. With this, we have moved to the end of this video. I hope the concept of subquery, its types, where to use, where not to use, all those things that I have discussed with you are pretty much clear to you. If you found this video helpful, don't forget to hit that like button, subscribe for more high quality technical content. Drop your question in comments and I will be happy to answer them. See you in the next one. Bye-bye.